Hey everyone, Jay here, and today we're going to go over another Python lab 7.17. This time we're going to use a loop inside of a loop. Right? This is going to be a two-dimensional loop. Right? Oftentimes we'll use this to loop through a two-dimensional array, or in this case, we're going to compare every single item in one array to every single item in another array. Right? So that means I have my two arrays right here. I have a list of the prime numbers up to 30, and then I have a list of some randomly generated numbers between 1 and 30. And I'm going to compare every item in my list to every item in prime numbers and see which ones are prime and which ones are not prime. And then output either prime or not prime at the end. All right, so let's get started. First, we're going to loop through my list first, this one here. And loop through my list first. It's important to know which loop you're going to do first, the outer loop versus the inner loop, because that's going to dictate the rest of your code within those loops. Okay. Uh, Technically speaking, I suppose pretty much all the time you can do them either way, but if you flip-flop them, it can become much more difficult to kind of figure out in your head and then much more difficult to code as a result. So I'm going through the way that I would think about it. I'm going to loop through each element in my list first, look at the first element in my list, and then compare it to every element in the prime numbers to see if it's prime. Then I'm going to go to the second element in my list and then compare it to every element of the prime number list to see if that's prime, and so on. So my first loop is going to go through every element in my list. That I'm choosing to use a while loop rather than a for loop. A for loop would be easier to write the loop. I could just say for I in my list and then go through my list, but then I would have the I value would be equal to the value in the list, but I wouldn't be able to then access the complete list. I'm much more familiar with, of course, much more happy using the while loop and then accessing my list using my list sub I rather than just using the value of I. So I is going to be just the numbers, the index numbers for that list. And then I have to remember to increment I at the end. Okay, so while I, starting with 0, while I is less than the length of my list, do all this stuff, and then I plus equals 1. Can you see that? There we go. Okay, so that's the beginning. Oop, just this part. Start I at 0 and then loop through until I is equal to whatever the length of my list is. In this case, it's 20, but we don't necessarily always know how long our lists are, so I'm using the len or length function. And then at the very end, I'm incrementing I. I'm doing it at the end because I'm using the value of I in the middle of this. Okay. So I've done that, and then I'm doing a little administration here. I'm setting my trigger, or not really my trigger, but my result, prime is equal to false. So I'm saying I'm going to go through this number and check the first number. First number is 14. Okay, I start by the default to say it's not false. And then I'm going to loop through all the prime numbers and compare. So I'm using I and J. It's common in programming. I is the first iterator for a loop. If we have loops inside of loop, so we go I, then J, then K, and we don't too often get beyond K, but if we did, we would just probably continue on with the alphabet. That way it's very easy to know which step in the loop you are because they're just incrementing by one. It's, kind of makes sense. The loop is incrementing, your variable names are incrementing as well if you have loops within loops. So it's very easy to keep track of things like that. If you name your incrementer something else, you have to remember what that name is. If you name it the same every time, it's going to become second nature to you soon enough. So second loop, we're using j as the incrementer, while j is less than whatever the length of the prime numbers list is. So we're going to move through all of that. I'm going to add 1 to j every time. And then the only thing we're doing inside the loop is if the value of my list at index I is equal to the value of prime numbers at index j, if they're equal, which means that, let's say if I got to the second one and I got to 3 in my list, when I went to the first number in prime numbers, they would not be equal. When I get to the second number, they would be equal, and then I would say prime is true. And then that's it, right? If they are not equal, I'm not doing anything. And we're just looping through here. And then at the end of the second loop, once, or well, I'm still in the first loop, but I've finished the second loop. Now I know, right? Prime is false by default. If I've changed it to true, I'll print the number, whatever the number is prime. If I have not changed it to true, it will still be false, and then I will output the number, whatever that value is not prime. And then you can see an example of my output right here. Right? 14 is not prime, 3 is prime, 6 is not prime, 15 is not prime, 2 is prime, and so on. And 1 is not prime. 1's kind of a special case in prime numbers. If we wanted to make this a little bit more enhanced in terms of processing capability, we could, let's say we got in here in the test and prime is true, just like when I did the number 3 as an example, I found that prime was true by the second prime number list. I don't have to test the rest of them. I know prime is true. I know it's not going to be equal to 3 and also equal to some other value. So I could prematurely say prime is true, but also j equals whatever the length of prime numbers is. Okay? And that will trigger the loop to end the next time it comes around because j will no longer be less than the length of the prime numbers. And so this will operate much more quickly. So every time, except for when it's equal to 29, if it's prime and it's equal to anything less than 29, I will get to skip at least one cycle of the loop. And so this will become much more efficient. As soon as I know it's true, I can stop checking. So that's optional. And we'll put a little optional performance enhancement, all right, is to quit early once I find a true comparison. Okay. Once I find it's true, I can stop testing. I know it's not going to be true twice. I know it doesn't matter if the rest of them are false. Of course they're going to be. If 3 is equal to 3, it's never going to be equal to any of the numbers after 3. So I could do that. There is definitely some option in like manufacturing and some other things to actually order this list in an optional fashion. We're not talking about that. We're just putting them in the correct order, but we do have the option of terminating this second loop early once we find a positive value, because we know we're not going to find more than one positive value or one true comparison. So that's an option there. And that's it. That's a loop inside of a loop. We're comparing every single value of the first loop to every single value of the second loop. I might just flip flop those and make it a little bit easier to understand. I'm trying to be confusing on purpose, right? There we go. That's going to do that. And thanks for watching. I'll see you next time.